So our next topic is multi-threading. So using GCD and OperationQueue, we achieve multi-threading in iOS. So at least one thread is there in every iOS application, which is main thread. And so multi-threading is nothing but performing tasks concurrently by scheduling them on multiple threads. Okay, so that will help on improve the application's performance. So I will explain one example. Like if you put any networking call in your view controllers, let's say view did load. So before some layout setup, so you will have to wait for the network call to execute before the view will load. So that's incredibly bad. So actually both the users who might think like it is a crash because it is taking time, and any other time it is taking. So users try to uninstall that app because there is no responsiveness. So for that multi-threading is used. So we can see, so for this concurrency and parallelism, these two things are important. So thread content processes and run constant concurrently. So concurrency means that two tasks can start, run, or and complete in overlapping time periods. So parallelism is like about performing work at the same time. So these are the difference between these two. So like time slicing can enable concurrency if only one thread or another core is available. So concurrency could benefit from parallelism. So iOS software need to work concurrently with other tasks. Okay, so whether it's are parallel or not. Okay, so as you see in the this example, if tasks did not support concurrency, they could not be stopped. So in the app, this would be rather terminal for the app that can put into the background by the user. So you can see at concurrency means at a time one is going and overlapping time period. Okay, so and this is the example of parallelism. So two threads are parallelly working. So we'll see like how that GCD is used. Okay, so GCD is nothing but Grand Central Dispatch, which is low-level API for managing operation, which was Objective-C developed, and we can use it asynchronously or synchronously. And it is very helpful for managing heavy tasks on the background, so that we can improve the app's responsiveness. So common use case of GCD is when making network requests that can import a large amount of data into the app. So locking the user interface, or we can say freeze for the user, is unacceptable. So there must be a better solution. So concurrent solution could solve this issue by checking the background thread without interrupting the user. So then updating the interface when the information is received. So this abstraction prevents us from needing to use the thread directly, and we can create a queue of task and hand it off to the GCD. Okay, so GCD manages the shared thread pool and allow you to add a block of code or dispatch queues. Okay, so we can see like how this is work. So I will open Xcode. We'll create so we will understand this on the playground. No need to create any application. So I'll just use new, then playground. We'll select blank my background to. This is not needed. So we need to understand and sync and async task. So sync dispatching means that the thread where the task is dispatched has to pause and finish executing the task before resuming. And async means like thread can be dispatched and does not wait for the other task to finish executing. So example using the main queue, we'll see here. So we write dispatch queue. async, and here we will write one for loop. Let's say for I like 1 to 5, and we'll print something. So here we'll print standard async task number that I, and once that done, we'll just print is done. Okay, I will see to run this app. It's taking some time here. Okay, so we can see output here. The done is print first, then async task loop is print like task 1 2 3 4 5. So now if we call this main thread, uh, so with async task, so this is async, we just change with sync and try to run this. We'll see what happens. Yes, it gives us the error. So this is a, this will crash, so that's why it is giving error. Since we are on the main thread already, the dispatch queues like main dot sync disclosure above cannot complete until its surrounding context is complete. So effectively we have to change this code. Okay, so we'll just use uh, something printing here first, and then something like this, and we'll just remove this code right now. Dispatch queue dot sync again. So we just delog this one. So we just print here. Sorry, deadlocked. Okay. So now I will try to run again. This gives the same error. Okay. So we need to check the thread actually. So the earlier code we had like for loop one. Just go back there. Okay. So we just need to check if this is the main thread. So we can check using threads object thread dot is main thread, and on main thread we can add this loop. Okay, and if it's not main thread, we can just directly do the same way earlier we had. So we just cut paste this above, and else part will be the same that we write earlier. So just cut this and paste here in else part, and here we can again use this one. Okay, so we'll try to run this. So you can see the standard async. We can just sync, change the name as sync. So that will be helpful to understand. So this is sync task, that synchronous task, and it runs the loop with 1 2 3 4 5, and then that done print statement is worked. So if two serial async tasks are asked to complete in serial, they will execute one by another. So that means we can just change back to sync one, sorry, async one. I will just comment out this code if we need in future. Okay, so this was the earlier code. Okay, and if we parallelly add another async task, so let's say to understand, it's 10 to 50. This is async tasks. just run again. It's taking some time. Okay, so it was because of async we need. Okay. So you can see 1, 2, 3, 4, 5, and then 10 to 15. So these two tasks asynchronously worked here. So what about then concurrent tasks? So for concurrent, we need to use dispatch queue. Okay, so that dispatch queue with some configuration updated one. So here we can add dispatch queue with predefined label, or we can say few more are there. We can use label and attributes. So label will be like concurrent. You can add any label, and then it should have attributes. So attributes we can define as a concurrent one, because we are using this in playground. It is not giving us autocorrect things correctly, so we just try to use whatever we get. So this is, we can say this is first concurrent task. So similarly we can do this for the other one, so that we have two queues. So I'll just replace this with this, and we can just write second concurrent task. So for better understanding, I will just this 6 to 10. Okay, so first we so now we need to see will it work as per the concurrency as we explained. See here, two threads are concurrently worked here, so that's why we get 6, 7, 8, and 10, and 1, 2, 3, 4, 5. But concurrently 6, 1, 7, 2, it happens like this. So here the output happens to be like in second or first order. This is expected behavior actually. So we only guarantee that the first tasks are completed in order, and the second are task are likely wise in the complete in that order. So if they should be printed in serial, the serial queue should be used, so that we are earlier used. And if you don't want to the block that thread, so alternative approach is used concurrent thread. So we can just but we need to call that as sync. So but we have to wait for the first task to finish before entering the second if we use sync. In if as we use async, no need to uh, wait for the other task. So all the above code using dispatch queue within a closure is known as a task. So with any number of lines to be executed within the closure. So another task can be added, creating another closure again with any number of lines. Okay, so we'll now learn about the queues. Okay, so queues are either serial or concurrent, and serial queues, as we discussed, serial queues are finished one by one, while concurrent queue like this one, so that can't guarantee which task will be completed first. So the order is not fixed in this case in the concurrent. So and the main queue is likely to lock the interface if made to perform heavier tasks and provide a poor it provides poor user experience. So mostly UI related things are on the main queue. So there is QoS, which is quality of service user interactive for the main queue. So we'll learn like what are the quality of service available in the queues. So, and another type is private queue. So private queues are serial by default and guarantee that the tasks are performed in a traditional queue, like FIFO order, first in first out order. So it is possible to make private queues concurrent, but it should be recognized that the standard GCD queues are concurrent, and it would usually be sensible to use one of those. So concurrent queues, or we can say global dispatch queues, these are the concurrent queues, so can run tasks simultaneously, although tasks to initiate their order that they are added to queue. There are four predefined global concurrent queues that can be used, and set the priority for those. So these global queues are accessed within the quality of service attribute to the queue. So as I mentioned, quality of service, there are four types of quality of service. So I just write here because it is making too much theoretical. So can just add comments here, and that I will add the names of the quality of service. Okay, so quality of service are like user interactive, and then user initiative, user initiated, and then utility, and then background. So these four types of quality of services are available for the queues. So these levels are like self-explanatory. You can say like user interactive means user interaction on the device. So that blocks, and for that you use user interaction, and same for user initiated. If user perform any action to that particular that particular screen, that will be used here. So background is like some background heavy tasks like downloading and uploading tasks. Those are very heavy tasks, so that should be on the background. Okay, so we'll learn like what is dispatch group. So if there are group of operation where you need to know when they have all like when they have finished, dispatch group can be used. So using the quality of service you can use. So how to use this quality of service we can learn here. I'll just remove all the code here. Okay, so we'll write let queue equal to dispatch queue, and we just add label on current queue and its attributes. Attribute is concurrent. Now we'll, as we learned this earlier, we just we use the dispatch group here. So we'll create object from the dispatch group, like work group for the dispatch group. So this async should have group. We'll just use group here. Let this execute out. Okay, so this group we can just pass this group here and use this group here. We just print anything. Task one done. Similar way we can just create another one. Task 2 is done, and when that work group done, we can just notify. Item not needed. We just use the queue that we already created, and like can print once that done. So, next one. So once we run this, we can see task 1 done, task 2 done, and then finish all. You can try one more time. Okay. So normally using this task 1, task 2, this is not the order. It can be worked in any other order, like task 2 may be done first, then task 1, but the notify will work after the both the. So essentially it does not matter, like if task 1 or task 2 finishes first, uh, like, and we could experiment with the sleep to give examples, or behavior is lower than the other one. So we are only interested when both tasks finish. So when the both tasks finish, this is the main part where we just execute that one. So right now this is happening like the same order, task 1, task 2, but it's not matter, like every time it will not do in the same order in the real examples. So this is very small example, that's why it's not happening. We'll try. Okay, so and so alternative to use this, like once we enter that particular group, so we can use some methods like enter method and leave method after you want to leave that particular block. So also there is a wait also. So we'll learn like how to use this. So we have work group already. So we have already created queue as well. Okay, so we'll change. So we'll not use this group here, and we can just enter that group using that enter and leave methods. So you can just write here work group and then enter. Okay, so you can just enter into this group. You can do whatever things like downloading or uploading things. That could be here. And once that done, we can just leave this group. So that is work group dot leave. Similar way, you can just remove this. And similar way, you can do enter and leave the group. Leave this one. Okay, so once this finish, then we will print this. So instead of notify, we can directly add this, and we'll just wait to finish other one. So we'll use work group here to wait. Okay, so run this time. So same way it worked. Okay, so here it will enter in the first async task, and then it will finish everything downloading. So I haven't added any downloading or uploading part because it will take some time. We just print that particular thing. Instead of printing, we will have some networking calls here. Once that done, then only leave this group. Till time this will execute. Same for the other task, and this line will get executed once this two operations done. So this two operation will be very heavy in the real scenarios. So then only we can just write the will execute the below code. So operations is built on the GCD. So that is Cocoa framework, which is iOS framework, is high level abstraction of GCD. So there are benefits using the operation because it offers features on top of the GCD. So dependencies or observables or pause or cancel, resume. So that things can be happen using the operation. So we have already queues, like we have to use uh, OperationQueue.main to update the UI related thing. And also we have some custom operation queues which can be created, and we can adjust the maximum concurrency operation in the queue as well as suspend or resume the execution. Okay. So next thing is like using background thread. So background execution. So as we have main thread, so similar way we can have background thread. So like extending your app's background execution time to ensure that you have time to perform some critical tasks. So for tasks that require more background time, we can use background tasks. So when your app moves to the background, the system calls the app delegates application did enter background method. So we can, so that method has 5 seconds to perform any task and return. So if we see your application, so I will just open one of the application. Suppose we have created this Swift package manager demo. Go to the app delegate. Okay. So in app delegate, you can just write this method did enter background. So this method will get executed once your app enters in the background. So as I mentioned, this method has 5 seconds to do some perform some task and a return. So shortly after that method return, the system puts your application in the suspended state. So for most apps, 5 seconds is enough to perform any critical task. But if you need more time, you can ask UI kit to extend your app's runtime. So that extending runtime by calling begin background task, that is one of the method. So that will give the extra time to perform some important tasks. Okay, so basically this is only for doing such background execution. And yeah, so that's it for this session. Yeah, thank you.